Okay, in this problem, we're applying the same principles that we've been doing before where we looked at beams, but this time we're going to do a more complicated structure and show how you can use the same kind of principles to solve the problem. Okay, so in this problem, we're having a structure that's on a grid. Okay, so think of this as made out of steel, and it's got this kind of crazy looking shape. All right, it's pinned at point A, and there's a roller at point B. And so that I don't have to put dimensions everywhere, let's just use a grid, and every point on the grid, all the spacing on the grid is 1 meter. All right, so we can read off distances. For example, this distance right here between pin A and the 200 Newton force is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 meters. All right, so we've got all the dimensions on the problem just by looking at the scale. Okay, so the first thing we do to solve this problem is we do a free body diagram. Okay, so I'm going to erase this and see if I can't just capture all this so I don't have to redraw everything. All right, and paste this here. There's a free body diagram, and we have point A. All right, since that's a pin, we know it's got a Y direction and an X direction. All right, and point B, we know that is a roller, and so it can only have a normal force. All right, so that would be force B here. All right, so there's our free body diagram. And what we know is sum of forces in the X direction is equal to 0. Sum of forces in the Y direction equals 0. Sum of moments about any point, whatever point you want to choose, is equal to 0. All right, so it's the standard approach to solving the problem. All right, so let's get started. All right, sum of forces in the X direction. So far, everything we've done hasn't had an X component, okay? But this time, we look and we see that AX is moving to the right, so that gets a positive term in the summation. And then we do have, looking over here, we do have another X direction force, and so that would be moving back to the left, so minus 150 is equal to 0. All right, we took care of both of the X direction forces, these two forces. All right, now let's look at the Y direction. All right, so we see there's several things in the Y direction, 1, 2, 3, 4 forces in the Y direction, so we just sum those together. We have AY moving up, we have B moving up, we have 200 newtons moving down, we have 300 moving down. Sum of all those is equal to 0. Okay, so making good progress. We have 2 equations at this point, but 3 unknowns. We don't know AY, we don't know AX, and we don't know B. All right, so we can choose a point and do sum of moments about any point to try to solve the rest of the problem. And I've given you the hint before that because a moment is not generated when the line of action goes through the point, usually we use that to eliminate one of the variables. So I'm going to choose point A because point A actually, if you look at point A up here, point A has 2 forces going through it, and those won't show up in the moment equations because the moment due to those forces is 0 at point A. Okay, so let's keep going then. All right, so let's first of all take care of the 300 Newton force. We see that that's 1, 2, 3, 4, 5, 6 units away. The moment arm is 6. All right, so 6 times 300 All right, and that's generating, remember we want counterclockwise to be positive. That's generating a clockwise motion if you exerted that force in the downward direction. Okay, so 6 times 300, since it's clockwise, it needs a minus sign. All right, now let's look at the 200 Newton force. Okay, the 200 Newton force, the moment arm is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so that's 11 times 200. And again, it's clockwise, so we need a minus sign. Okay, now moving on to the 150 Newton force. Okay, we need to know the moment arm, and remember, you can slide this to show it. All right, so if the line of action moves this way, okay, so the perpendicular distance is 3. All right, that's the closest that gets. Okay, so hopefully you understand what I'm saying. All right, so we do 3. You know, I'm breaking a line here. So plus 3 times 150. All right, this is generating again a clockwise motion, so that would need a minus sign as well. Okay, so we've taken care of 300 Newton, the 200 Newton, the 150 Newton. Now we need to take care of the unknown force B. All right, so the moment arm, again, the line of action, you can see you need to count. Let me change colors so you can see my count. I need to know what the moment arm is, and so in my head I envision moving this line of action up. Okay, and so if it were right along this line of action, you can see that perpendicular distance. All right, so we count that. That would be 1, hang on. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 times B. But notice that B generates a counterclockwise rotation, and so this would get a plus sign on it. Okay, so all that is equal to 0. All right, so we're feeling pretty good about that because I look at this equation that was generated, the only thing that's unknown here is B. Okay, so we can solve for B, back substitute, and get AY. All right, AX is also easy because there's only one equation or one unknown in that equation. So when you solve these equations, you get that AX is equal to 150 newtons, and then you get that AY is minus 56.2 newtons, which means that AY is 56.2 newtons working downward, because we had initially referenced that upward and we got a minus sign. So minus 56.2 newtons up is equivalent to 56.2 newtons down. And then finally the force B is 556 newtons working up. Okay, so that's the solution to this problem.